So I will discuss theory, then meanwhile cluster will create. Yeah, inside instance only we have to install Helm. Interact the cluster, not cluster inside Helm not required. Understand? Helm not interact directly with the pod. Your client machine will interact to cluster. Helm commands you are running inside EC2, right? Or not inside cluster, right? Helm command will enter inside the EC2, but process will execute inside the cluster. Understand? To run that Helm, I need one server, right? I'm using the client server. Yeah. But process will initiate into the cluster inside only. Yeah. But command will execute inside the client. Why? Request has to go control node. Request will go to control node. From there to worker node it will go. So how to interact control node? By our client machine only. Control node is not correct. Kubernetes, 30 to 40% we can easily learn. Remaining just we have to focus. Hmm? We are using CD, Argo CD, right? Yeah. That's it only. Pushing AML, Helm, AMLs we are push. That's it. Okay. The concept now I'm going to start. Install git hyphen. I can take SSH also. Oh, sorry. Inside the server, right? Okay, before that I should create a cluster. Then I will discuss the concept, theoretical concepts for 15 minutes. Okay. Yeah, let's go to create a cluster. So I need to change region. Oh, I am also need to create. So ECS Far Gateway clear, right? How to work with that normally. So I have already taken workshop, right? ECS, EKS. The difference is what, anyone? ECS, small scale applications, yeah. ECS also, yeah. ECS is a AWS owned service. EKS just wrapper on the Kubernetes. ECS also combination of nodes, combination of Far Gateway we can create. EKS also same. Okay. So let's go to GitHub. Let's understand. So guys, ingress is clear, right? Namespace is clear, right? Horizontal scaling, services, work node components. What about cluster autoscaler? Working or not? No, no, inside the cluster, it should show the nodes. But Argo CD inside, it won't show the nodes. Argo CD inside running for nodes only we can see. Clear? Anyone had to try this? Complete? Huh? Today. Today, good day. Hello. ఏంటి? Today. Oh, today is what? Thursday, right? You guys are Thursday fans, huh? Yesterday busy with help. Okay, no problem. Today what time? ఇంకేమనుకోలేదా టైమ్? Afternoon? After class? In lab only directly? Okay, welcome. What about you? You only. You only. Done, huh? Done. Oh, super. Done. మనమే. Huh? Today. Just I want to know from your end. What's the challenges to complete this concept yesterday? Whoever pending, I'm asking you only. I'm not point outing one person. What are the challenges to complete yesterday? Except busy, please say another answer. Job and busy. Internally. When pod is pending state. Pod is not there any resources to schedule. Automatical node has to create. Understand? Your node fully occupied by the pod. I need one more node. Pod is waiting. Then auto scaling will create automatically. No, 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 no. We just, you can put maximum set point. Same like auto scaling group only. No, no. That's what I'm saying. Kubernetes EKS by default not providing auto scaling inbuilt feature. We need to install controller. The main reason, I will tell you, the main reason, most of the cases, auto scaling group we can disable actually. We can go for at a time 2, 3 nodes. We can keep same nodes only. I will tell you reason also. A big application require auto scaling, but small application, if something node is deleted, for example, 3 nodes are there, two pods are there. One node is through, if it is an auto scaling group, because of no load, one node is deleted. The node and only one pod is there. The pod will move into existing node. Okay. But this existing node, the pod already there, one more pod in the existing node, application not down. But only pod is there, that node only deleted means the pod will be move into existing node. This time your application will down. Understand? So by default they are not providing. If need you can enable. You are using multiple replicas, 4, 5, 6. Then no worries. Auto scaling group is required. Even auto scaling group terminate any node. Minimum replicas 6, 7 there, so that you don't need to any worry. But replicas are 1, 2, 3, 4, 1, 2 only, for example. Challenges will come. That's what they are not giving inbuilt feature, this process by default. Even you are creating a servers, right? If you create a servers, automatically auto scaling group create any servers until you configure. Leave it Kubernetes. I'm talking about AWS. AWS by default not giving a feature. If required, you can opt. Same Kubernetes also. They are not giving by default feature. If required, you can configure. If they give, it's not in your control. Development time, testing time. Why unnecessary required? If required, I can enable. Otherwise, leave it. That's what. Okay. Argo CD clear. So I'm going to explain. Rolling concepts clear, right? Almost completed. The concepts are pending: schedules, monitoring, headless communication, config secrets, RBAC, stateful volumes. It will require 4 to 5 days. Let's go to monitoring. Okay. We already discussed same concept on EC2. Right? By using Grafana Prometheus, we already monitor a matrix load, CPU, RAM, and all. Right or not? But my application directly deployed on instance, there I just monitored my instance load. But now your application not directly deploy on server, deploy on pod. Pod consuming resources from the node. Understand? So pod is taking some RAM and CPUs. Node also giving some resources to pod. We need to understand node load, pod load. Application consumes the resources from the pod. Pod consumes resources from the node. Right? So I want to know the right. So present load on the node, present load on the pod, RAM and CPU. So in this case, we can take a Grafana Prometheus concept on Kubernetes. Same concept I have seen on the directly EC2, now directly on Kubernetes cluster. I want to see the node load and the pod load. Clear? Okay. I think you know what is Grafana, right? You know what is Prometheus. Prometheus is a interface between your application. I mean, it will collect the metrics from the source and give to Grafana. Grafana will give a dashboard. Whatever Prometheus will give a query. Prometheus itself, there is no dashboard. So I need one dashboard provider. So Grafana I'm taking. Clear now? Okay. So cluster is creating. Meanwhile, if you are having any questions, you can ask. Yeah, Helm inside ingress already ML there, right? Hmm. Service you can give cluster IP, yeah. Yeah, see, when you take ingress, service should be cluster IP, right? Understand or not? Ingress, if you are using, cluster IP should be required. You no need to do any changes. You can deploy directly, give a path. Directly, when you deploy, ingress load balancer will create automatically. That ingress load balancer is based on the path, it will call a service. Service name, you can give ingress.yaml. Understand? Yeah. No need to change service type. Service type same only. Madam, Argo CD is a concept. Whatever you give, it will run. Argo CD don't know this is ingress. Argo CD don't know this is service.yaml. Same like a Jenkins. Argo CD job is what? See, that's what I'm thinking. You don't always, many students, Argo CD, Helm, be confused. Argo CD job is deployment tool. If you give Python code, Python.yaml also, it will deploy Python code. Understand? If you give a path, Argo CD job is whatever you can give, it will deploy. That's it. You can understand manually how you are going to run, that will take care by Argo CD. That's it. Helm is there. How you are running manually? I don't want to run manually. I don't want to connect cluster directly. Then do one thing. Push your YAML files into GitHub. Argo CD will interact and run. By default, Argo CD will run all YAML files inside. Clear? Clear? Not clear? Huh? So, security related workshop series already started. Last Saturday, I have discussed how to work with security group source in real time and NACL. So on next workshop, but I'm just thinking for this week, Saturday, should I conduct or not? Long weekend, right? Friday, Saturday, Sunday. That's what I'm thinking. What do you say? Long holidays. Yeah. That's what I'm saying. Sunday, I'm thinking. Workshops only Sundays, by the way. Online only. If I'm taking offline, no one is showing interest. Better. I have changed completely my decision. So only online, but I don't want to take this Sunday. Take rest. 3 days holidays. Go to your hometowns. Mm. I mean, holidays means not institute holidays. If you are working, they are holidays. Okay? Yeah. Institute is there. I'm here only. Friday class is there. Means tomorrow. Saturday also class is there. Common. If required, I will give Saturday relief. Required? Huh? Your wish. Your wish, guys. Topics are there. Don't worry, guys. What will happen? One day may extend. Nothing will happen, right? But long holidays, right? Attend Friday, relax Saturday, Sunday. Event by Okay. Saturday, take. No class. But Friday, tomorrow is there, okay? Saturday, Sunday, whatever your wish. Rest or practice. Practice already done. Take a rest. Saturday, Sunday. Okay, don't think anything. I'm not going to give any task. I'm not disturb you in the group also. Okay, let's get started. But don't think I have a plans, huh? I'm free only. I'm not going anywhere. No. IPL, no IPL. Next match is Wednesday, right? Yeah. Notes are there, right? Two notes are running. Today match, No, match is not in Hyderabad. SRH Mumbai, match is in Wankhede Stadium, Mumbai, right? So, yeah. But Wednesday match is same Mumbai, Hyderabad in here only. 21st or 23rd? 23rd. How much ticket? Leave that, huh? Tickets are too costly. 1500. No. 15,000 ticket. 17. Okay, no pods are there, right? Okay, let's go to the concept. Nirmala. Correct. Okay, guys, let's go to a Grafana Prometheus concept. I will take this workshop, guys, this month only EFK, but you need to practice before the all Kubernetes concepts. No Grafana Prometheus. Yeah, here only. This is the internal architecture of Grafana Prometheus. If you are interested, you can have a look. Otherwise, leave it now. How Grafana Prometheus will come. Prerequisite help. Help is what? Yeah. So this is my medium only. Blocks. Just give my name. You can. Yeah. I'm going to deploy I'm going to deploy Grafana Prometheus through Helm. Understand? Helm will call these repositories and deploy. Helm is a package manager, right? By using Helm, you can deploy your application. They can deploy their application. They are giving same place lo petti తీసుకొచ్చుకుంటా. Okay? Yeah. In this case, I'm using Helm to deploy Grafana Prometheus. Or Grafana Prometheus you can deploy through Git also. The YAML files are there in Git. kubectl apply -f Grafana Prometheus YAML files. Anything is fine. Finally, Grafana Prometheus should be installed. Right? Even Linux is to also Grafana Prometheus you can install anyway, right? Different ways. Finally, those should be run inside. So now, yeah, you can install Helm by using this process also. Or yesterday I have already shown you, right? Control F. Go to Helm first. WK till here. Okay. From now, minimum 4 hours practice required. Minimum. It's a minimum, not max. Minimum 4 hours practice required from now to get a job. You learn whatever you learn, you need to revise. Okay. Again, why he use Helm? Helm is a package manager for Kubernetes. Helm simplifies the installation process and all. You can. You know what is Prometheus? Is an open source monitoring tool, provide a out of the box monitoring capabilities of Kubernetes container orchestration platform. Collect the metrics from the server and pods, and it will give to Grafana. Grafana will visualize the dashboard. Helm repo. These are the comments by using Helm how to add a Grafana Prometheus. So Helm charts are there. Grafana Prometheus Helm charts. So I'm going to add that repo into my cluster. After that, I will run the charts. I'm adding a charts. I mean, if you go inside this charts place, you can see Grafana YAML files, Prometheus YAML files, values.yaml files. I'm going to run now. So I'm going to add Prometheus. Yeah, let's go here. Added Prometheus also added. Yeah, number of YAML files. Helm charts means number of YAML files. Yesterday we have seen, right? Charts, chart.yaml, tasks. So I'm creating a namespace is Prometheus. You know what is namespace, right? Now, install means what? Install, Helm install means what? Apply. Okay. So after that, you can check a pods if you want to check. Which namespace? Hyphen Prometheus. These pods are, you can see here. See now, this is still creating, okay. So Prometheus pods are running now. So now you can see service also. So you can see Grafana service also, Prometheus service also. The background it is running. Through Helm I have uploaded YAML files of Grafana Prometheus where it has stored already. So now I'm going to see this Grafana Prometheus, the background. Pods and all. So all pods are running, Grafana Prometheus pods running, Grafana Prometheus services also running. Now what should I do now? Go to service. All are which type of services is are? What should I do? Edit the service, node port or load balance. Let's go and check now. Now I'm going to edit Prometheus service. So after that I can see Prometheus dashboard. I'm going to give a node port. Next you can take same Grafana also service. So Prometheus already done now. This is done. Service editing. Next go for this service also. Grafana also I'm going to do changes. Node port done. So now I have edited two files. One is Grafana, one is Yeah, now you can see, you are able to see two node ports. One is for Prometheus, one is for Grafana. So let's go to check Grafana 1, 32408. So before that, you can go and check a instances. Yeah, you can enable a security. I'm giving all traffic. So now you can take here, not this, right? kubectl get nodes -o void. Commands are clear, right? Kubernetes commands, no doubts, right? Yeah. You can take so node IP 32408. This is Grafana dashboard. Let's take one more one. Node port 32441. This is Prometheus. You can run any query also, you will get a matrix. But this is not friendly dashboard. But Grafana is a friendly dashboard. So from there you can easily control which node load you need, which pod load you need. So Grafana is admin. You can take a password also. There connected a load balancer. You can take a node port only. So where you can collect a Grafana password, you can run this command secrets. So prom operator is a password. Okay. So this is Grafana Prometheus. Okay. Next, go to home, dashboards. So these are the dashboards. Go to new, click on the import. So you can take any number. I'm taking 1.760 and just load. Okay. Select your Prometheus, import. So you can see total load here. Which namespace it is? Cube system namespace. If you select Prometheus, Prometheus namespace inside pods. If I select cube system inside pods, you can see. Now, number of pods, all right. You can see these are the number of pods is running. If you want to check a specific pod, you can apply. You can see specific pod load, CPU use, number of CPU request, memory use. Okay, if you select all, you can see all pod, each container, pod inside container, you can see a very low level here. So the process, you can see minimum max MB, staking, memory and all. You can see graph format also here. So, but my end, if I select a cluster inside Prometheus, okay, but here namespace, default namespace is not there. The reason my cluster inside nothing is running, right? Except existing namespace process. So I'm going to create a sample pods. In that case, I can take day 2 workloads. Okay, let me apply now. ls cd day 2 kubectl apply -f dot. Okay. Now, if I go and check here, refresh, I should select 1 second. You can give refresh. Yeah, updated. See, okay. Default namespace. See, my end, only one pod is running. Default namespace. So that is Nginx pod. This is the container. You can see the used memory. Total Nginx, the container is taking this one. Total. Clear now? You can see here kubectl get pods. Which namespace these are? Default namespace, right? Okay, let's go and check these pods are there or not. See, my app, whatever I have seen here, my app, Nginx, WebRS, same pods I'm able to see are not here. You can select my app pod. This is my app pod load. So no load, right? What you can do? So already we have discussed horizontal autoscaling pod, right? Horizontal pod autoscaler time we ran stress command, right? I mean, for loop hitting number of requests, right? So if you need a better clarity, configure Grafana Prometheus and you can configure horizontal pod autoscaling. So when the load will increase, automatically pod will increase, you can easily see experience here. Clear what I'm trying to say? Yeah. So number of styles are there. So you can create one more dashboard also. A different style, different experience. Click on the load here. Select a Prometheus, import. You can see a different block. Each code, the background, each ID, it will give a different UI. Okay, these are the default UIs. You can select anyone. Clear? How to check a load of pod and node by using Grafana Prometheus. This is the process. So refresh 10 seconds. If you can put automatically, it will be refresh every 10 seconds. You can see the load of the node and pod. So you can check these are the different dashboards. If you want to check your pods, I think it's a different dashboard. Sorry. Where the project is running, there where you need to install this. You need to do everything. I will explain the project, right? After explain the project, I will give the task, what you need to do. So same project you can implement Helm. Like that, I will give the tasks. Implement. I mean, if you are combining all the concepts in one project, we will get a clarity. Hmm? It's a simple only Grafana Prometheus, nothing is that. Just configure and access dashboard and we can see. Hmm? Yeah, metrics. Only metrics. Logs. Again, a big story is their logs. Logs we already discussed about Splunk, CloudWatch, right? Here there is a concept EFK or ELK concept is there. EFK concept means this is okay. This is only metrics, not logs application. For example, one pod is fail. From here, you can't, get the information why pod is fail. Here you can see pod load is 0. That's it. But the reason, correct reason, you can see in the logs inside only. The logs you need to pull. See, every 10 minutes, 10 seconds it's refreshing. The logs you need to collect and give a dashboard like Splunk or CloudWatch. So here the concept is there, Elasticsearch, Fluentbit, Kibana, EFK. Collect the logs, store the logs, display the logs. This is the concept. I will see. Till here clear? Okay. So there is a concept in the Kubernetes, Grafana Prometheus. The concept is low key. Low key concept. Low key means if you install the low key agent in the Grafana Prometheus where they're running, you can see logs also, application logs also. But Grafana Prometheus is only for design metrics. Even if you enable install a specific agents also, you won't get a rich features from there. It's just okay. That's it. So that's what we can go for a different process like a Splunk or CloudWatch or Kibana. We can take any one of the example. Okay? Yeah. Okay. Next concept is okay. Small concept I need to take. Volumes are a very big concept. Volumes and schedules. RBAC. Maybe not complete. Config. Oh, volumes is required. Okay, then I'll start a process. Then we can continue tomorrow also. I'm going to start schedules now. Okay, a very important concept, guys. Very, very important concept. We have a 4 type of schedules, 5 type of schedules in Kubernetes. One is daemon set, node affinity preferred, node affinity required, node selector, taint and toleration. Okay, these are the concepts. Today class, I will discuss daemon set, node selector. Tomorrow class, I will discuss node affinity, preferred, required, and taint and toleration. Okay. And Monday onwards, we are going to start volumes and stateful set. Very interesting concept, stateful set. Stateful set, what is stateful set? Just I'm saying, we use for the, mostly we can use this process for the database applications. If my pod is deleted, new pod will create or not? Same name or different name? Huh? Different name. But same application, if you run through stateful, same name will come, not different name. What is the use of name here? Database applications require the same name. Read replica delete means read replica only create. Master delete means master only should create. Otherwise, if it will create a different names, your application, backend application not communicate to database. Backend application inside already we have added the name of the database. Endpoint contains name or not? Name there or not? If you give a delete a pod and create a new pod name, your backend not communicate to database. That's what we can go for stateful set application. Present we are working stateless. So pod delete means no need to track same pod required. Every pod is same. Every pod will create from the same image only. Right or not? The pod will create after 1 year. Pod will delete after 1 year. And fresh pod will create now. Both are same. Both pods are just redirecting a request only, not to store anything. But database pod, one year running pod delete means 1 year data will lose. database data will be load. Understand the difference here. That's what stateful is mandatory, volumes are mandatory. Okay. Monday onwards, we can start slowly. Very important concept. Project also I will show Monday, Tuesday, Wednesday. The project and the pending concepts. So Thursday onwards, I will start GCP. Okay. And finally, Ansible. Okay. So let's start the guys. Are you able to attend 10:30 a.m. 1 week? Or if challenges are there, I'll ask them to attend 9 a.m. Is there any challenges to attend 10:30 a.m. 1 week? If no means I will combine GCP both. We can save at least one week. Otherwise, there and also 1 week extra. Okay. Okay, no problem means I will move to 10:30 last week only. Either GCP or Ansible. Yeah. Very interesting now. Daemon set. What is daemon set? Clear, get Grafana Prometheus clear, right? Okay. What is daemon set? The logs concept, if you need to understand, application logs, how to configure in Kubernetes, if you need to understand, these schedules or dependencies are there. So we need to understand the schedule. Let's go to the paint. Schedules. Guess who will schedule the pod? Scheduler. And on which basis by considering the deploy a pod into the node? Resource available. It's a default behavior. Now, custom schedules, if you create a inside the YAML file, that will take care. Schedulers will follow your instructions only. I need pod in one node only, second node only. That you can give the instructions. In that cases, we have different instructions are there. The first instruction is daemon set. This instruction is a simple logic. If I create a pod through daemon set, how it will work? Your end, two worker nodes are there. So the daemon set logic is each pod, each node. Understand? Each pod, each node concept. Each pod, each node. If I run daemon set, how many pods will create? 2. No replica set concept. Daemon set n. If you create a pod through daemon set.yaml, you no need to specify how many pods. Each pod, each node concept only. Car keys? Okay. So each pod, each node here, let me show you the daemon set.yaml, you can understand. Is there a replica entry? No. No replica entry. If I run now, let me show you. kubectl delete -f dot. Okay. I'm deleting a default namespace inside all the workloads. Okay. Let's switch to kubectl get pods Nothing is there. ls, so cd day 8 schedules. Okay, so let me apply kubectl get pods. Anything is there? Nothing is there. Kubectl apply -f a demonset.ml. How many pods will create? One or two? Two. Let's check first node. Kubectl get nodes. Two nodes are there, right? Now, how many pods will be run? Two. If my node will increase, pod will increase or not? We don't know, right? Let me show you. So, kubectl get pods. Clear? Each pod, each node. There is no replica entry in the YAML file. Yes, YAML file, once again I'm saying, you no need to worry about YAML file. Compare the YAML files. 90% all YAML files are the only same. Daemon set means matter here, kind daemon set only will come. Here, deployment YAML, daemon set YAML difference is what? Pod level, no difference. Kind level difference only there. Next, deployment inside replica entry is there. Daemon set entry, daemon set inside no replica. These changes you need to find out in update somewhere so that you can easily understand. YAML to YAML, a 10 to 5% change only there. Understand? Okay. So for example, let's go to the nodes, auto scaling group. You tell me if I increase the node, one more pod will create or not? This is my question. Kubectl get nodes. Still to, let's wait. Third node is creating. How much time it is taking? Running. Now you can check 3 nodes. What about pods? 2 or 3? Clear now? Daemon set as a controller. The daemon set controller job is one node, one pod. That's it. Okay. Now a question to you. Kubectl delete pod. If I delete a pod, one more pod will create or not? Huh? Clear now? Each pod, each node, even node delete, pod delete or not? If my node delete, pod delete. Node create, pod create. Pod delete, pod create. All actions always node equal to pod. The daemon set job is. In which use case daemon set use? Good question. Now, my log agent is there. CloudWatch log agent is there, for example, or monitoring log agent. The agent I can run through daemon set. The agent image is ready. Splunk image is ready, for example. Splunk should run each node, right? Each node or not? Two node logs you need to pull, two node metrics you need to pull means. So definitely the Splunk should run two nodes. First, if it is running into the Kubernetes means Splunk should be in the image. Docker Hub, you can go to Docker Hub, see the Splunk image is there. Kibana image is there. How to deploy this image? Through daemon-set YAML. What is the benefits? You should run each node in each pod. For example, if you not specify, your scheduler may run two pods in same node. Splunk will collect the logs for only one node, not second node. But daemon set, one pod, one node. Splunk will run this node, Splunk will run second node. Clear the concept? Yeah. No, node level also we required. Pod level plus node level. Pod runs on any node, pod logs you can collect. But node logs, definitely you should pull all nodes logs. All nodes means the agent should run each node. The agent should run on each node means daemon set we can take. This is one of the great example. Daemon set is clear. Daemon set is clear. Next. Next concept is node selector. Node selector.yaml. Let's go. These are concepts are easy, but once we enter into the taint and toleration, you need to remember so many use cases. Now here also so many use cases. So my suggestion is write each and every point. Otherwise 100% you will forget. If you are not done these points. Daemon set each condition. Someone can take initiative, please write and send it to the group otherwise. 4 condition daemon set, right? Node increase, pod increase, node delete, pod delete, pod delete, pod also create. One node, one pod. That's 4 points. That's it. Next, node selector, just your deployment YAML file is same only. But here if you can see, node selector, just I'm giving color equal to pink or country equal to India, like that. If you, for example, here, color equal to black or white, you can give something. So these are labels. Understand? These are the labels. In this case, let's go to my node selector. So till here, your deployment at YAML only. Only the change this entry. I'm saying select this pod. You can select this node only. In this case, you need to enable the same label for node also. Node labeling first. So pod should be match labeled node only. So if I say color equal to pink, your node should be labeled with pink. Otherwise, this pod is not going to be scheduled on any node. Hey scheduler, you don't schedule default manner now. You have to follow what I can say. This is node selector. I'm selecting a node specifically now. This pod should land on the labels matching node only. In this case, let's go to here. You can start the process now. So node selector, I'm here, right? So first we need to label the node. Okay. In this case, please wait, you will get a clarity. I haven't finished. So let's go to here. Okay. kubectl. My 3 nodes are there. Any one node you can label with same key values. So this is my node. Okay, copy. So go to here. I'm going to here adding my node. Okay. Okay. Not updating region now. Okay, then no problem. Let's change now till here. Remove. So add this node. Clear? So color equal to just give a CLR pink like this. I'm going to label this node now. So this is the command label. A label node, node name, label key, label value. Key label key is what? CLR. Value pink. Node name is this one. Label. Clear now? Anything. You can give anything. Okay. Now see, this node is labeled, right? Now, VI node selector. So this pod can, these pods, two pods can schedule on this node only. How pod can communicate node based on the label. My node also labeled color equal to pink. Your pod also labeled selector in the selector only color equal to pink. Both label match only, this pod can schedule on the specific node. Until on that, this pod is pending state only. Scheduler is not decided to schedule anywhere. Okay, this is custom actions. By default, scheduler will follow. Now, if you mention, it will follow your instructions only. Now, let's apply kubectl, apply -f, nodes selector.ml. Now, kubectl get pods. Two pods are running, right? How do I know these pods are running which node? -o, why? You tell me, these two pods running on same node or not? So definitely this is not default behavior, right? Default behavior is what? One pod on one node or at least scheduler will follow. But now my and three nodes are there, but two pods are running in the same node only. You can open even insert. You can give 4. What happened? Pending state. Why these are pending state? I'm taking T to small only now. Okay, let's take okay. So pod is, two pods are running in the one node, right? So the node is not accepting one more pod. But two more nodes are there, right? But the two more nodes not allow this pod as per the condition. In this case, what should I do? I can label same label for one more node. Clear or not? Or I can remove the condition or increase the node or increase instance type. We have so many options. Clear the concept now? Okay. Now, after schedule a pod on node, I'm going to unlabel the node. Unlabel means just give, remove the value and just give key name and here hyphen. Unlabeled. Okay. Now you can go and check kubectl get pods running or not. Still pending. Okay, let's wait. Okay, very clear. Why my pods are not scheduled on unlabeled node also? Hmm? Hmm. What I have given here? Condition. Any node is, any node is, any node is matching with this label, no? No. So labels are not matching. But already running pods also there, right? Running pods, is there an impact? No. Only scheduled time only it will work. Those pods already scheduled. After that, if you remove the label also, no problem. But whatever pods are ready to schedule, those pods impact is there, not matching the label. In this case, what should I do? Either you can remove this condition here, pod level or node level. Clear what I'm trying to say? Yeah. For example, if I remove these two conditions, what will happen now? Default. See, running. Clear now? These two parts already, whatever parts you can see, 239, 239 before running, right? Now see, yeah, 192.609. Okay, my end, how many nodes are there? kubectl get nodes hyphen o while. Yeah, see, on this node now no pods are running. It's a default behavior. So immediately your scheduler follows this requirement as per the schedule basis. Node level no restrictions, pod level no restrictions. Clear or not? So again, if I label the node, for example, here 239 is there, right? This one. Okay, if I enable any restrictions, kubectl get nodes. If I enable any restrictions, 220 and already pod running, right? Okay. Running pod, is there an impact? I'm taking here. Copy. Again, I'm labeling the node. Node label. Is there any problem for existing pods? No problem. This condition only work schedule time only. Okay. Now go to VI node. Again here. Okay. This is container level. Huh? Container level. See. Okay, let's now apply. What is the expected one now? What you observe? Huh? All pods are in only matched label node only. So whenever pod insert changes you modified, hey pod, you need to schedule on this node only. Condition you are giving, right? Condition are you giving and you are applying again. So request will go to API. API will inform to scheduler. Scheduler will, okay, there is a condition for this pod. So we have to be deploy on the matched label node only. I found one node as a matched label. We can deploy these pods all are into the matched label node. So deployed into the matched label. Again, if unlabeled node, is there any problem? Nothing. Clear? Until you modify in the pod YAML file, no changes. If you modify in the pod level again, request will go to scheduler, right? Definitely, it has to be followed as per the condition. Clear what I'm trying to say? Yeah. Auto scaling in killer coda. Yeah, you can practice, but it won't increase the nodes. Why? Killer coda not offering auto scaling, right? Auto scaling is a AWS service. Clear the concept node selector. Practice node selector different cases. Nodes already there, right? Changing the different pod level labels, node level labels. Observe it each and every step. Okay. Yeah. Thank you. Bye.